Introducing the Intralogistics Optimization Starter Kit by Grid Dynamics. In this demo, we'll demonstrate how to optimize warehouse intralogistics and reduce labor costs using a digital twin approach in NVIDIA Omniverse. Warehouse optimization presents real challenges for today's operations teams. When you don't have the tools to manage your warehouse layout properly, align it with picking needs, and evaluate changes in a digital environment, it causes workers to travel excessive distances. High-demand products are scattered, forcing pickers to zigzag through long aisles instead of using efficient routes. These misaligned layouts lead to congestion in high-traffic areas, slowing workflows and creating unexpected bottlenecks. Testing layout changes is limited to costly real-world experiments, risking downtime and operational disruptions when adjustments fail to deliver results. These inefficiencies, combined with rare layout updates to avoid risks, make it harder to meet growing order volumes, tight shipping deadlines, and control labor costs effectively. Intralogistics Optimization provides a standardized approach to solving these challenges. The solution combines an optimization engine with a digital twin of your warehouse, built in NVIDIA Omniverse Isaac Sim, to simulate and compare layouts under real-world operational conditions. Your inventory data and order history feed the optimization engine, which recommends optimal product placements and picking routes tailored to your facility. These placements and routes are loaded into Omniverse to perform simulations that account for worker-robot path intersections, loading-unloading times, and movement velocities. This allows for precise performance estimates across various workload scenarios, enabling direct comparisons between different warehouse configurations. In this virtual environment, you can instantly reorganize inventory, simulate new workflows, and quantify performance gains. After validating reduced travel times and increased throughput in the digital twin, implement these precise changes in your physical warehouse. This eliminates guesswork, delivers immediate operational improvements, and ensures your facility adapts seamlessly to fluctuating demand cycles. The expected outcomes? Decreased order fulfillment times through improved picking routes and strategic product placement, reduced labor expenses by minimizing unnecessary movement and overtime hours, adaptable layouts that prepare you for seasonal demand fluctuations, and the ability to test improvements virtually, verifying results before implementation. Let's dive into the demo to see it in action. We'll begin by creating the foundation of the digital warehouse. Here you can see the first rack being placed in the scene, then duplicated to form a row of 3 racks. Now that entire row is copied to quickly build a second. Notice how this simple process makes it incredibly easy to lay out basic warehouse structures in NVIDIA Omniverse. Now that the racks are in place, it's time to introduce conveyor belts to handle item movement. Watch as a single conveyor belt is dropped in, duplicated multiple times, and arranged into rows to form a cargo drop-off area. A quick physics test demonstrates boxes traveling smoothly on the belts, showing how items will flow during picking and packing. Next, it's time to assemble the entire facility. The warehouse extension tool automatically generates walls, floors, and overhead structures around the existing racks and conveyors. In just a few clicks, what was a bare scene transforms into a full-scale warehouse environment, ready for simulation. Let's take a quick tour through the newly created warehouse. This fly-through shows the spatial relationships between racks, belts, and loading zones. It's a great way to spot any missed details in the layout and visualize how workers or robots will navigate in the final design. To enable path planning, a traversal graph is overlaid on the warehouse floor. This graph represents all possible routes for pickers or robots, connecting each aisle, rack, and conveyor area in the facility. Here's the simplified graph with 3D assets removed, showing just the traversal network. This view makes it easier to verify nodes and edges are correctly configured for efficient movement. With the traversal graph in place, let's watch a simulation of an actual order collection path. Look at how this robot navigates from rack to rack, following the nodes of the graph to pick items based on a predefined pick list. Let's zoom in for a closer look at the robot's picking actions. See how items are retrieved from racks and placed on AGVs. Each small motion you're watching is governed by the physics and path logic defined earlier. This level of detail ensures realistic behavior when testing different picking strategies. From this corner angle, you can really see how the robot's routes mesh with the overall warehouse flow. This perspective offers a holistic view that helps identify potential congestion zones or space constraints that might not be obvious from other viewpoints. Once an item is picked, it travels on the conveyor belt toward its final destination. This demonstrates how boxes flow seamlessly through the warehouse, mirroring real-world processes. So far, you've seen a fully functional digital twin, a 3D warehouse complete with racks, conveyors, and an underlying traversal graph. Now let's walk through the 8-step optimization process that computes an optimal product layout to shorten travel time and boost throughput. First, the traversal graph is digitized. Each pickable slot, aisle intersection, or conveyor station becomes a node, with every valid path between them as an edge. This structure lets us calculate exactly how costly it is to move between any 2 points. Second, historical order data is compiled from transaction logs. This reveals which items customers typically purchase together, valuable information for clustering them in nearby slots and reducing unnecessary walking time. Third, traversal costs are computed by building a distance matrix. This shows precisely how expensive it is to move between any 2 points, factoring in physical distance, time, or even path congestion. Fourth, product co-occurrence is calculated using a frequency matrix. This shows how often products appear in the same order. Items frequently bought together should ideally be stored near each other, minimizing back and forth during order fulfillment. Fifth, knobs are defined as binary variables. Think of each knob as a simple on-off switch indicating whether a particular product is assigned to a particular slot. All possible product slot combinations are created, ensuring each knob can be toggled in the solver. This step formalizes the slotting problem into a discrete optimization model. Sixth, constraints are set for these knobs. After all, each product can only be in one place at a time, and each slot can hold at most one product. Seventh, the cost of each knob combination is computed using those frequency and distance matrices we created earlier. When frequently co-purchased products are placed far apart, costs go up. When they're placed close together, costs go down. Finally, the total cost is minimized as the solver evaluates thousands of possible configurations to find that perfect layout where frequently co-ordered products require the least travel distance. The end result? A data-driven product placement plan that's ready for testing before making any physical changes to the actual warehouse. After running the solver, you can see it generates a JSON file that maps each product to a specific rack location. To prove the concept works, 2 simulation experiments are run. One with a random product layout that took about 2,612 seconds to fulfill 100 orders, and another with the optimized layout that took roughly 2,507 seconds. That's an improvement of over 100 seconds. These metrics clearly confirm that the new product placement strategy shortens travel times, paving the way for significant efficiency gains when implemented in a physical facility. To experience how Intralogistics Optimization can transform your operations, schedule a discovery session with our technology experts today.